Perfect.
Okay, so the last time we spoke about objects on an inclined plane. So just conceptualize it. If you have something on an inclined plane and a grade, so this is a grade and it's going to have a certain angle, okay? So once you have an object on an inclined plane and a grade, there is a tendency for it to slide downwards. It's going to slide downwards. And the reason why it's going to slide downwards is because when you look at the force of gravity is usually vertical, straight down. The force of gravity can be divided into its component parts. This force of gravity actually have two parts to it. It has what we call a parallel portion, and when we say parallel, it's parallel to the inclined surface. It has a parallel portion and a perpendicular portion. It is this parallel portion that's going to pull the object down the inclined surface. And that is why objects on an inclined plane, there's a tendency for it to slide down the inclined plane. And what I showed you the last time was that this force going down the inclined plane, this force, parallel force, which is going down the inclined plane, is equal to the sine of the angle times the force due to gravity. So the parallel, the parallel component or the parallel force parallel to the inclined surface that's pulling the object down the inclined surface is equal to the force due to gravity. And of course, the force due to gravity is the mass of the object times the acceleration due to gravity times the sine of the angle. And there's also a perpendicular component to the so this force of gravity can be resolved into its parallel component and perpendicular component perpendicular to the surface. This perpendicular component is what we call the normal force. The normal force of an object on an incline is perpendicular to the inclined surface. So this perpendicular component is equal to perpendicular component is equal to the cosine times the force due to gravity. And the force due to gravity is the mass of the object times the acceleration due to gravity. You have to remember that. So the way you understand these problems is to do questions related to these problems. So let's look at our first question. All right. So in diagram A, you have this cart, which is on an inclined surface, 45 degrees. Okay. And they ask you what is the normal force and what is the net force. Okay. All right. So let's think about it. So 45 degrees of inclination, force of gravity is always vertical, so it's going to be straight down. So you have to draw the forces that's going to act on it. So remember, when you resolve your force due to gravity, there's going to be a component that's going to be parallel to the surface. Okay? So there's going to be this component which is parallel to the surface. Okay? So the normal force, remember what we said, the normal force is equal to the mass of the object times the acceleration due to gravity times the cosine of the angle, right? That's the normal force. times the cosine of the angle. Okay, so that's cosine theta. So that's cosine 45 degrees. So let's call this force N, which for normal force. Okay, so the mass of the object is 1,000 kilograms. Sorry, yeah, 1,000 kilograms.
Can see anything.
The mass is 1,000 kilograms. So it's 1,000 kilograms times the acceleration due to gravity. Okay? All right. The acceleration due to gravity is 9.8 meters per second squared. Right? 9.8 meters per
I
second.
can't see anything, Dr. Smith.
Okay. All right. So again, I'll tell you what, let's start over since you couldn't see anything. Okay. Okay. So again, when you have an object in an inclined plane, that object is going to be subjected to a number of forces. The force due to gravity is going to be vertical, and when you resolve the force due to gravity, you resolve it into its parallel component and its vertical components, or its perpendicular component. So parallel component and the perpendicular component. Parallel to the inclined surface, perpendicular to the inclined surface. It is this parallel component of the force of gravity which is going to pull the object down the inclined surface. And the perpendicular component is what we call the normal force. Now, this inclined angle is going to be the same as this angle there, and I showed you how it is. So using trigonometry formulas, this parallel component of the force of gravity is equal to the force of gravity times the sine of the angle, and the perpendicular component is equal to the force of gravity times the cosine of the angle. So this is what you're going to get. So the parallel component is equal to the force due to gravity times the sine of the angle, and the perpendicular component is equal to the force due to gravity times the cosine of the angle. So let's do this problem. So you have a cart on an inclined surface 45 degrees, and the question asks to find the normal force, to find the acceleration, and to find the net force. All right, so first thing you have to do is find the normal force and the parallel. Remember, this normal force is perpendicular to the surface. It's not going to affect this object moving down the incline. The force that's going to pull the object down the incline is the parallel component of gravity. So anyway, let's calculate the normal force. So we know that the normal force, as we mentioned before, the normal force, object on an incline, is equal to the force due to gravity, which is the mass times the acceleration due to gravity times the cosine of the angle. Okay? Okay. So the mass of the cart is 1,000 kilograms. Acceleration due to gravity is 9.8 meters per second square. And the cosine of 45 degrees, the cosine of 45 degrees is point, 0.85. So the so the cosine of I think it's point. All right, let's look for the cosine. So you take out your little calculator. Okay, so when you get a problem like that, you have to take out your calculator. So you take out your calculator and you put cosine 45 degrees, and that's equal to 0.7. So that's 0.71. So that's 0.71. So that's equal to, so that's 980 times 0.71. So let's see what that is. So that's going to be the normal force, right? So that's 980 and that's equal to 696. So that's a normal force. So remember, the normal force is not gonna make the object move down so that's 696 newtons. The normal force is acting perpendicular to the surface. It's not gonna make the object move down the incline. The force that's gonna make the object move down the incline, that's a parallel component of the force due to gravity. That is equal to the mass times acceleration of the object, which is 980, times the sine of the angle. Okay? So it's 980 mass times acceleration times the sine of the angle. And the sine of 45 degrees is 0.85. So sine of, that's 0.85. So you just pull out your calculator and you look for sine for 45 degrees. So that comes out to 8 833. Okay. So this is actually, there's this is supposed to be another zero right there. Okay. So 0.85 times 98, 9,800. That comes out to be 8,330 newtons. There's supposed to be a zero right there. Okay. All right. So the perpendicular sorry, the vertical, The parallel component, which is pulling this cart downwards, is this force. Okay, so the force that pulling this cart downwards is 8,330 newtons. So this is actually the net force. This is the net force pulling the cart downwards. From Newton's second law, we know that the force is equal to the mass times the acceleration of the object. So this net force is the parallel component of the force of gravity. But you have to calculate the acceleration now. You know the net force. The net force is this force which is pulling the object down the inclined surface. So to get the acceleration, you just rearrange your equation, and the acceleration is equal to the force divided by the mass. So the force is 8,330, and when you divide it by the mass of 1,000, right, so you get 8.33, and the unit is meters per second squared because it's the metric unit. Okay, it's acceleration. So by just looking at what's going on, you can calculate the acceleration that this car is going to achieve, knowing the incline of knowing the angle of inclination and the mass of the cart. Okay, so all right, let's do it for this one now. So we incline the surface a little bit more, everything remains the same, and let's see. All right, so let's erase this one. All right, so same situation but a greater inclination. So we know the normal force. The normal force is all right. Let's do the problem. Let's not eliminate it. So the normal force is equal to the force due to gravity, which is the mass times the acceleration due to gravity times the cosine of the angle. And so cosine of 60. And you have to use your calculator to give you that, okay? So again, the mass is 1,000 kilograms. Acceleration due to gravity is 9.8 meters per second squared. And the cosine of 60 degrees. So you go to your calculator, you get cosine, you put 60 degrees in, and that comes out to 0.5. So the cosine of 60 is 0.5. Okay. So this is 9,800 times 0.5. So 9,800, and you divide it by a half. And you have So you get so you get 4,900, and that's Newton. Okay. All right. So we know the normal force is that. Okay. So the normal force is that. All right. All right. So the parallel component. So the parallel component to the inclined surface. So the force that's going to pull it down the inclined surface is is uh, is the mass times the acceleration. So acceleration is 9.8. Okay, times the sine of the angle. So the sine of 60, sorry, sine of 60 degrees. Okay, so this is 9,800 times the sine of 60. Um, so you look in your calculator again. It's the only way to do it. So the sine of 60, okay, that is 0.87. Okay, so the sine is 0.87. So you get 9,800 times 0.87 times 0.87. And that's equal to, all right, so so we're going to times 9800, and that gives us, 1 second, 9800 times 0.87, and that is 8,526. That's the amount of force pulling the object down the inclined surface. So that's the force pulling this cart down the inclined surface. So this is actually the net force, because the normal force is perpendicular to the surface. It's not going to affect the object, the cart moving down the surface, right? So it is only the component that's parallel to the inclined plane that's going to pull the object down the inclined plane. So again, Newton's second law, we know that the net force is equal to the mass of the object times the acceleration of the object. So To get the acceleration, the acceleration is equal to the force divided by the mass. And the net force is 8,526. So 8,526 divided by the mass, and the mass is 1,000 kilograms. So you get 8.526. Okay? So you get 8.526. What you should observe is that for this one, the acceleration was 8.3. But as the incline gets, as it get more inclined, as the angle increase, you can see that the acceleration increase. So again, remember, physics is just telling you what goes on with motion. Well, we're doing mechanics. It just tells us what everyday motion is like. So if you have an object on a greater inclined surface, it's going to have a greater acceleration down that inclined surface. Because we move from 45 degrees to 60 degrees, everything remains the same, but the acceleration actually increase. So the greater the slope of an incline, going to be the greater the acceleration of an object down that incline. So that is, what we want to show you here, just using, basic physics to look at that. All right, so let's move on. All right, so let's look at this problem now. This is a different problem, but the same principle. So there are three lab partners. You have Olive N. Glevnew, Glenn Brook, and Warren Peace. They're discussing an incline problem. See the diagram. They're debating the value of the normal force on this object on an inclined surface. Olive claims that the normal force is 250 newtons. Glenn claims that the normal force is 433 newtons. And Warren claims that the normal force is 500. While all three answers seems reasonable, only one is correct. So indicate which two answers are wrong and explain why they're wrong. All right. So, we're going to use our knowledge of objects on an inclined surface. Okay, so the frictional force, usually go in the opposite direction to the motion. So the normal force is perpendicular to the inclined surface, and the parallel component of the force that's going to pull the object down the inclined surface, is going to, let's draw that so we fully understand what's going on. So the force that's going to pull the object down the inclined surface is going to be like that. It's going to be parallel to the surface, the inclined surface. All right. So we know that the angle of inclination, we know the force due to gravity. So, we can calculate the normal force. We can calculate the normal force, So we have all the information to calculate the normal force. And again, the normal force is equal to the force due to gravity, which is mass times the acceleration due to gravity. They gave us that component. It's 500. So the mass times the force due to gravity is 500 times the cosine of the angle times the cosine of the angle. and it's cosine 30 degrees. Okay, so this is normal force. So that is equal to 500 times the cosine of 30. And the cosine of 30 is 0.86. So you look in your user calculator, cosine of 30 is 0.86. And when you calculate that, it comes out to 433. All right, so we know that Glenn is correct, but they didn't ask you, if Glenn is correct. Say, indicate which two answers are wrong and explain why they're wrong. So we know that. Okay, so Olive claims that the normal force is 250. Okay, so what she's saying is that the normal force is a half times the force due to gravity, and that so she is definitely wrong. The normal force is not half of the force due to gravity. And then Warren claims that the normal force is 500 newtons. We know that the force due to gravity is 500 newtons. The normal force is going to be less than the force due to gravity, because the force due to gravity, when you resolve it into its component parts, you have a parallel and a perpendicular component. And each of these components is going to be less than the force due to gravity, right? So Warren is very, very wrong. It if the surface was flat, on a flat surface, then the normal force will be the same as the force due to gravity. But on an incline, it is less. Okay. All right. So let's look at another problem. Let's erase that. All right. So let's look at this problem now. This landscaper is doing some lawn work when a 2 kilogram tire escapes from his wheelbarrow and begins rolling down a steep hill. It's a 30 degrees incline in San Francisco. They want you to sketch the parallel and perpendicular component of his weight vector, this weight vector. Determine the magnitude of its component using trigonometric function. Then determine the acceleration of the tire. You're going to ignore uh, uh, resistance force. Okay, so of course the tire got away from him. The inclined surface is 30 degrees. As you know, the force due to gravity is always vertically straight down. The normal force is perpendicular to the surface, and then the parallel component, which is parallel to the incline, is going to pull the tire. That is why the tire is going to roll down the inclined surface, because there's a parallel component which is pulling the tire downward. Frictional force is going to be in the opposite direction. Okay, so they want you to determine the acceleration of the tire. So you have to calculate the parallel component, which is going to pull. This is the net force, which is going to pull the tire down. So that net force, as we have been saying, the parallel component of that force is equal to the mass of the tire times the acceleration due to gravity times the sine of the angle. Sine of the angle. The angle is 30 degrees. Okay? So the mass of the tire is 2. Acceleration due to gravity is 9.8. And the sine of 30 degrees is, so you, again, you go to your your computer, I mean your calculator, okay? You go to your calculator and you look for sine 30, and sine 30 is 0.5, okay? So sine of 30 is 0.5 times 0.5. So that will be, that's 9.8. So that's 9.8 newtons. So the net force pulling the tire down the inclined surface is 9.8 newtons. Okay? They want you to calculate the acceleration though. But using Newton's second law, we know that the force, the net force that is, the net force, force net is equal to the mass of the object times acceleration. So the acceleration is equal to the net force. And we know the net force is 9.8. So that's 9.8 divided by the mass, and the mass is 2 kilograms. So that acceleration is 4.9 meters per second squared. So 4.9 meters per second squared. You can also write it meters and second to the minus 2. All right, so the tire got away from a landscaper and it's rolling down the inclined surface, 30 degrees. You can calculate how fast it's going to go. By the net force acting on this is going to be, we ignore the friction. Let's say ignore that friction, okay? So the net force is the parallel component to the inclined surface. And again, the parallel component of the force due to gravity is the force due to gravity times the sine of the angle, which is 9.8. That's a net force. Net force is equal to mass times acceleration. So to get the acceleration, you have to divide the net force by the mass, and you get that. All right, so I think you fully understand that. So let's do another problem then. All right, so let's do another problem. So to fully understand these concepts, you have to do problems. Okay. So question 7: in each of the following diagrams, a 100 kilogram box is sliding down a frictional surface at a constant speed. Okay, so this is the speed, it's constant speed. The incline angle is different in each situation. Analyze each diagram and fill in the blanks. So we have an inclined surface, 30 degrees, we have this object which is sliding down the inclined surface. It has a constant speed, and they gave us the speed. So they want you to calculate the normal force, they want you to calculate the frictional force, and they want you to calculate the force due to gravity. All right. So, let's approach this problem. Um, we can calculate the force due to gravity. All right. The force due to gravity. Force due to gravity is the mass of the object times the acceleration due to gravity. And the acceleration due to gravity close to the Earth's surface is a fixed number, 9.8 meters per second squared. So the mass is at 100 kilograms, and the acceleration due to gravity is 9.8. So 100 times that is, so the force, let's give everybody their correct symbol, force due to gravity. So that is equal to 980 newtons. So the force due to gravity is 980 newtons. Okay? Because we know that the force due to gravity is the mass times the acceleration. We can calculate the normal force because we have been doing problems, objects in an incline. So we know that the normal force is equal to the mass times acceleration due to gravity times the cosine of the angle, the inclined angle, cosine of the angle, and it's 30 degrees, cosine of 30. All right, so again, the cosine of 30 is 0.87. So you plug in, so it's going to be 980. That's the mass times acceleration due to gravity times 0.87. Okay, use your calculator, look for cosine of 30.87, and that's going to be 849. So 849. So your normal force is 849. So you see your normal force, an object on an incline, the normal force is always less than the force due to gravity. Okay? Because it's a component. So now you just have to remember, stuff that you were taught in physics. We know that they tell you that this object is moving down a frictional surface at a constant speed, and they gave you the speed. At a constant speed, we know that the acceleration is zero. Remember? When you have an object with constant speed, acceleration is zero. You have to have a change in velocity, or a constant velocity, acceleration is zero. You have to have a change in velocity for you to have an acceleration. So what they're telling you is that the net force, remember, net force is equal to the mass times acceleration. Net force from Newton's second law. Net force is equal to the mass times the acceleration. So the mass of this object times its acceleration down the inclined surface is equal to the net force. So times the acceleration. Okay? So Newton's second law said that the net force, so this object is moving down the incline, so the net force will give you acceleration. But they tell you that it has a constant velocity, so the acceleration is zero. So what they're telling you is that the net force is zero, right? Because acceleration is zero, so the net force is zero. When you look at this object, the parallel component is going to pull it down the incline. Frictional force is going to pull it backwards. So the net force in this situation is the parallel component, which is pulling it down, minus the frictional component, which is pulling it upwards, right? But because it's moving at a constant velocity, the net force is zero. So when you solve this equation, you see that the parallel component, for that to occur, the parallel component of force, which is pulling it downward, will have to be equal to the frictional force. So for this object to be moving at a constant velocity, then the parallel component pulling it downwards is going to be balanced by the frictional force pulling it upward. All right. So we found this, we found that, and that. So the parallel component. So the parallel component of force, remember, that is equal to the parallel component is equal to the mass of the object times acceleration due to gravity times the sine of the angle times the sine of the angle. So sine of 30 degrees. And the sine of 30 is 0.5. Sine of 30 is 0.5. So this is going to be 980 times 0.5. So you're going to get 490. So the frictional force is 490 newtons. So, you know, take your time, use your knowledge of Newton's second law, and then just try and solve the problem. Okay. So let us do one more problem, and all right. So let's see. All right. Okay. So in this question is a part two of this. The same weight of the box, same constant speed, but now the angle was increased. The angle was increased to sorry. The angle was increased to 45 degrees. Okay, so let's do the problem. So the normal force again. So we know the normal force. No, so let's do the force due to gravity. The force due to gravity is equal to the mass. The mass was 100. The mass was 100 kilograms. and the acceleration due to gravity is 9.8. So the force due to gravity is 980 newtons. Okay. All right. So that's the force due to gravity. The normal force is equal to the force due to gravity times the cosine of the angle. So it's 980 times the cosine of 45. Cosine 45. So the cosine of 45 is 0.71. So this comes out to be 693. So 693. So the normal force is 693 newtons. And all right, so that's a normal force. The force that's going to pull the object, the force that's going to pull the object down the incline, that's the parallel component. That's a parallel component. And that is equal to the force due to gravity times the sine of the angle, sine of 30, sorry, sine of 45. So it's 980 times the sine 45. So you take your calculator, you look for sine 45, and what you're going to find is that the sine of 45 and the cosine of 45 is the same number. So it's the sine of 45 and the cosine of 45 is the same number. So it's 0.71. So you're going to get 693. So when you have an inclined surface of 45 degrees, you'll find that the normal component, which is perpendicular to the surface, the normal force is going to equal to the force that's pulling the object downward at 45 degrees. Okay, so the object is moving at a constant velocity, so therefore the acceleration is zero, as we determined before. Acceleration is zero, moving at a constant speed. For you to have acceleration, you have to have a change in velocity. So for the acceleration to be zero, then what we're saying is that the net force is zero. The net force, force net, is zero. So the net force will be the force pulling it down minus the force pulling it upwards. So the net force would be the parallel component of force minus the frictional force, right? That would be the net force. Well, we know that that net force is equal to zero because the acceleration is zero. So therefore, the frictional force will have to be equal to the parallel component. And we find that the parallel component is 693. So the frictional force is 693. So the things that we found out was that the more the more inclined the surface is, the greater the velocity. Sorry, the greater the acceleration. And then at 45 degrees, we see that the normal force is going to equal to the parallel component of force. Okay, so this basically covers force on an incline. Okay, using the same principles that we have been going over. So let's